The Patchwork package makes it incredibly easy to combine separate plots into the same graphic by using the simplest mathematical operators such as plus, slash, parentheses and much more. Since you are here, I'm sure you already have your beautiful plots. So I'll quickly create some plots for this demo, but I won't focus on them. Instead, let's get straight to the plot assembly. For example, to place multiple plots side by side, we can use a plus or a vertical bar. For stacking plots on top of each other, we'll simply use slashes between plots. Moreover, we can easily combine both vertical dash and slash in the same command to produce 2 by 2 or 3 by 1 multiplots. It's that simple. However, the lower picture in this layout is so unnaturally wide that my eyes start to hurt when I look at it a little longer. Sometimes, when we have plots of different width, we need to place a wide plot on one half of the page and two slim plots on the other half of the page. To achieve this, we can divide the page into two halves using a vertical bar and place two plots in one of the halves, either to the right or left of the vertical dash. If one of the plots is significantly taller than the other two, we can use half of the page for the tall plot and stack the two flat plots vertically on top of each other in the other half of the page. And as you can see, using parentheses is very important because they can completely change the layout of your plot. For instance, let's consider two multiplots that we have already created, where we put plots side by side and put a slash between them. When we don't use parentheses, the vertical dashes would split our multiplots horizontally into three equally sized spaces, where the middle space would consist of four small plots. However, when we use parentheses, we can split our multiplot into two vertical spaces. In this way, we can get ridiculously creative with the design of our plots. However, even with simple mathematical operations, the use of many names and symbols can quickly become cumbersome. To simplify the code even further, we can create building blocks. For instance, when we create two building blocks, each consisting of three side-by-side plots, stacking those blocks would put 6 plots on the same graph without excessive use of parentheses. Similarly, we can use the ggforce package to zoom in on a specific plot, displaying the zoomed in part as a separate picture beside the original one. We can then use a slash to place this complex figure below 3 other informative graphics. Additionally, we can easily control the size of the zoom by setting the zoom size argument higher than 1 for a wider zoom and lower than 1 for a more narrow zoom. But such control is completely optional. If you don't feel like controlling anything, you can relax, because Patchwork will try to keep the multiplot as square as possible, deciding for you how many rows and columns your final plot has. However, if you know exactly how many rows and columns you want, the plot layout command allows you to easily determine the dimensions of your plot. For instance, using 2 columns instead of 3. The only issue we have here is with the legends. They take away too much of valuable space and repeat themselves redundantly. To solve these problems, we can add the guides equals collect argument inside our layout. This would reduce the number of legends from 6 to 4 by removing 2 redundant ones and placing the remaining legends of different plot types on one side of the multiplot, freeing up a lot of space. However, similar legends from different plot types would still remain on the picture, so no important information would be lost. And while several ggplots of the same size fit nicely together, combining more sophisticated plots might produce odd shapes and proportions. For example, let's say we produce plots of ANOVA, chi-square test, model predictions, and the table of model results. and try to put them all on the same graph. Just look at this disproportional plot. The ANOVA picture contains a lot of information that is difficult to see, while the model prediction plot takes up a lot of space despite being almost empty. To control the proportions of plot on the grid, we can add the widths and heights arguments inside the plot layout function. Setting all values to 1 would create completely equal proportions for all 4 plots. However, the model predictions plot and the table still take up too much space, despite not showing much, while the ANOVA plot could use a bit more room. So let's improve that. By setting the width argument to 2 to 1, the left column will be twice as wide as the right column. Similarly, setting the heights argument to 2 to 1 would make the upper row of pictures twice as high as the lower row. Since both dimensions would reduce the size of the table by a factor of 2, our table would take up only 1/4 of the area of the ANOVA plot. Speaking of area, area is a small helper function used to specify a single area in a rectangular grid that should contain a plot. The area function has 4 intuitive arguments: top, left, bottom, and right, which allow you to determine the exact position of a plot on the grid. The usefulness of such layout design will be apparent in a moment, so please bear with me. For now, let's start by placing one plot in the first row and first column, the second plot in the second row and second column, and the third plot in the third row and third column, using only the top and left arguments. We can then use the design argument to apply our layout design to our multiplot. Adding other separate plots to the grid becomes completely intuitive. However, the real power of designing your own layout comes out when you start to use bottom and right placements in the area. For instance, defining 1 for the bottom and 3 for the right placement for the first plot would keep our plot on the first row but stretch it out over 3 columns, which is useful when we have wide plots. Similarly, using area 2131 would start our second plot on the second row and first column. Using 3 for the bottom would pull it to the third row, while 1 for the right would keep the plot in the first column, which is useful for tall plots. You get the idea. And this way, you can design your plot to your heart's content and even leave some empty space in the middle of the plot for a signature, photo, or simply for a dramatic effect. By the way, we can easily add an empty space with the plot spacer command, add some text using the text grub function from the grid package, or add a simple table via the table grub function from the grid extra package. Moreover, if we have limited space, we can overlay one picture on top of the other. For instance, we could place a table with contrasts between the 3 error bars to show how big the difference between them is and whether this difference is significant. While it's common to arrange multiple plots side by side, there are occasions when we desire the final result to present a cohesive and visually appealing narrative. This is where the plot annotation function becomes invaluable. With this function, we can not only set titles and captions, but also assign tags to subplots, enhancing the overall impact of the visualization. While the tags can be more sophisticated than simple numbers or capital letters, the Patchwork package documentation offers comprehensive details. However, I personally never needed to use anything beyond capital letters. The final point I'd like to mention before demonstrating how to save this plot is that you can incorporate any ggplot2 feature into your plot. The only distinction is that you use the and sign instead of the plus sign to introduce any new feature to all subplots within the patchwork. Once you are satisfied with your visualization, you can save it using the ggsave command in your preferred format, quality and size. And if you are satisfied with this video so far, please consider hitting the like button. Now, combining plots is useful, but to elevate your data science skills to another level, you should also learn how to combine tables, which will take you less than 5 minutes if you watch this video.